Hello, everybody. So we're about to wrap up module 2. These 16-week courses stretch out a long ways compared to the 8-week ones, which are finishing up module 8 or module 4, coming on the halfway point. So, couple of things tonight. Something that is useful, but it's more useful in other programming languages. And I wanted to make sure and at least talk about it a little, because for those on the software development pathway, one of the classes you'll have to take is mobile app development. And it's something that every other one of our major programming languages has. So it kind of shows up in day 1 of mobile app development, because it will be studied heavily in the 200 level course. But we don't really have it in Python, so just kind of talk about it some. And some notes about applying polymorphism. How do we make that useful? And we do have that aspect in Python. I just want to talk about the other one for a few minutes so that you're not taken by surprise when you get in your 264 class or something up to that level, and like on day 1, it'll seem like you're expected to know something. I have one announcement on here. Some of y'all heard this yesterday. There's an esports team around the Ivy Tech campuses. If you aren't familiar with that. And over the weekend, I heard from somebody at the, I think, Fort Wayne, either South Bend or Fort Wayne. One of those up in the northeast corner. But he wants to challenge the other campuses to an esports event at some point this semester. So if you're a gamer, please make sure and let me know that, and I'll put your name on the list and make sure you're informed of all that if you want to participate in it. Since we're already 4 weeks into the semester, I'm guessing that'll probably be near the end of the semester, middle of April, early May. But it's still in the very early planning stages. So if anybody's a gamer and wants to get on the esports team this spring, let me know. And, there'll hopefully be an event, possibly a scrimmage amongst a bunch of different Ivy Tech campuses, instead of just several small competitions have one big one. But that is that's something yet to come, because a lot of us are excited about it, and we don't want to let that fizzle out. So we try to make sure there's at least one event every semester, even if it's a little harder to get everybody together than it was 2 years ago, when most people were regularly on campus every day. It's a little easier to do team stuff back then, but it's still quite possible. And if things are done remotely, they're usually done on like a Friday afternoon when people can gather at the nearest campus. And we got Friday morning, Friday afternoon, when you're about the only person on campus, you get really, really good internet connection. But most people have decent connection anymore. So, yeah, if you're a gamer, let me know, and I'll make sure you at least get informed about that and stuff. If you're on the fence about it or whatever, you can decide later. So the thing I want to talk about this evening is really has to do with abstract classes, which we have abstract classes in Python. They don't get used very often, and we can kind of get around some of it, but we do have abstract classes. But there's another thing that goes with abstract classes in most programming languages that we do not have in Python at all. I want to talk about that for a moment, because you will see it in upcoming classes. A special type of class, the notation for it when we set them up looks very, very similar. It's called an interface. I'll go ahead and put that on the label. Interface and abstract classes. So it's very abstract. Unlike the one we were looking at the other day, the terminology we use for those would be concrete. And the abstract classes are things that we cannot make an object out of. We have to have a concrete class to make an object out of it. I'll get to those in a second. I just wanted to talk about interfaces because we don't have those. So the word interface itself, you've probably heard that word. It shows up all over our modern world. There's so many things. There's two definitions. There's a noun. These are straight out of the dictionary. A point where two systems interact. Or the verb definition of interact with another system. So obviously that's something we can do in software as well. A graphical user interface, the thing we're going to look at probably next Tuesday. We might get to it on Thursday. We're going to talk about lists and dictionaries and a couple other things first. Do a quick pass of those. But a graphical user interface is where a human would interface with application level software. Or a USB type A interface. It's where an external system, such as flash storage or a mouse or something external to the computer, interfaces with the operating system. And whenever we use these in software, it kind of applies to the physical ones there as well. So software interfaces are usually introduced with the words a list of rules software must follow. And that's kind of what that phrase is why I wanted to mention it, is for those who have to take the mobile app development course, you'll see that interfaces interact with interfaces pretty much on day one, which is a list of rules the software must follow. And if you haven't worked with interfaces at all, you might not understand why your program's not running. There won't be any errors, won't be any typos, won't be any issues. Won't be anything that makes the program crash. It just won't work because you're not following the rules the software must follow. Or that would apply to physical interfaces as well. Like I mentioned, USB type A. That's very explicit physical requirements. It has to be a certain length and width, with the distance between the little plugs and one side different than the distance between those plugs and the other side. I think everybody's experienced that. Go to plug up your flash drive and have to turn it over. It only goes in one way. It's very explicit. But we have similar things in software. The obvious usefulness of this is when other programmers are going to be using our software. Like we'll put together a package or something that other people are going to use, and then they'll use it to make objects. But we want to make sure that whatever it's used for is still can interface with anything else in the package. So we set up like a list of sort of a list of rules that things have to follow. I put a note here. So typically what we do is whenever we'll install our package or install our module and create their own objects with it and go to use stuff and call things from the module, we don't give them direct access to run. We'll, instead of running directly, we'll take the object they passed in and cast it into the interface, which is sort of a special type of class. And then we'll use our type instead of theirs, make sure it follows all the rules we laid for it. So it's kind of like the virtual version of the dimensions on a physical USB device. The things that make sure all the software is going to work together like it's supposed to. The list of rules. So that's for outsiders. It might be a little bit less obvious, but you'll probably see it before too long. After you graduate and get good jobs developing software, you might work on some decent size program, mid-size program, maybe 75,000 lines or something as part of a team, something that's going to take a while to put together. And are you going to remember what you did 6 or 9 months earlier? Because at that point, it's like you're the outsider using somebody else's software. That could be, that's like several seasons later. Maybe a vacation happened since then. Vacation, sick days, all sorts of stuff's happened. So in that case, kind of like you're the outsider, so it helps us too when we get to big things. What else did I remember? The rules offer a layer of protection against bad interaction. And yeah, I wanted to mention it and the word interface in particular. That way you won't be surprised. But really what it is it's all the basic idea of class the other day. Right? So this blueprint, the design for a data type that is built of some data fields, which are akin to variables. They're just enclosed in that nice little capsule of an object we're going to use. Everything's sealed up nicely there. And a bunch of methods to process that data. Well, an interface basically consists of a bunch of the methods, but only the method headers. They're abstract methods in that they haven't been wrote yet. And we do have abstract methods in Python. So now getting back to some Python stuff. A quick example that'll have just one abstract method to see the concept, how they work. And then an interface takes that to an extreme of it's only abstract methods and no data fields. Abstract classes, we still have data fields and can have data fields and methods and most of our class stuff, but there'll be some methods that we can't finish out, that we can't write when we make our class. And I have an example planned to highlight that in a moment. So just a few notes first. And like a lot of things in Python, it's not full abstraction. As you progress further in your studies, the word semi-static might show up. A lot of the stuff in Python is kind of like it's static. That word means there's only one copy. And it's not really static, but it's not fully independent like what we have in some of our other programming languages. So it's sort of static. So there's workarounds and the abstraction isn't enforced in Python like it is in other classes, but I wanted to at least look at it. What we have is this thing called abstract base class. We can extend. We can extend to create an abstract class. Or classes. We're just going to do a couple for a short example. Methods we can't write the code for. Actually create it. Y'all say it like that. So for abstract, it means methods we can't actually create yet. So at design time, but we know they will be there at runtime. So it's methods that we know we're going to have before the software ever runs. But when we're designing our classes, we might have no idea how to put those together or what would be involved. And this is the core idea of an interface. An interface is only those. It won't have the data fields. Our base class will have some data fields too. Although the example didn't really have any data fields to kind of be closer to an interface so that you'll know what, so they won't take you by surprise when you get to 264 class. As always, this is an active subject. So talking about like writing code that we can't really write, probably don't make a lot of sense. So let's see this in action. I meant to use the other computer because I haven't used Jupyter notebooks yet, but I have the example pulled up on that one. So I'll just use Spider again. That's definitely my favorite IDE. Or I can use Idle. I haven't used Idle yet. Google Colab. There's lots of options. Let's use Google Colab. I haven't used that. That's notebooks. That's what I was planning on using this evening for this first part. So you can just search Google Colab and get to this notebook, but like anything, it's a text editor. I call them all text editors, even the fanciest ones. It's a place to edit Unicode text into the syntax we want for Python. Yeah, so this is an online one. Jupyter Notebooks, the by far most popular notebook IDE, is open source. So Google kind of took that and ran with it as part of their Office suite. So it has all the features plus a few more things. There's one really nice thing that even Jupyter Notebook doesn't have, and that's all of the background stuff that we've periodically talked about in this class, the setting up the libraries, version control, which version of Python do we need to use. All of that was set up by some of the best programmers in the world, which makes it super, super easy because it's pretty much all automated. We don't have to worry about any of that stuff. And then the other advantages you get of working with Google Office Suite, you can share it with other people. Multiple people can work on it at the same time, all that stuff. Y'all are probably familiar with from the cloud. So where's the new button? Is it hidden behind my Zoom buttons or something? Oh, there it is. New notebook. I'll go over there so that thing stops flashing. So notebooks split our Python code up into cells, supposed to organize it. And since Python code is just Unicode text, basically, we can also explicitly have those as text files instead of code sorter files. So it separates them, and then notebooks also always run in browsers. So we can put HTML code there and make instead of using simple comments, we can put really nice HTML code in some of the cells to mark it up very clearly and document our code nicely. I'm just going to do the simple organization and put different steps. So in the first cell, well, I'll put some text here. So the first thing I wanted to do, is this cell? Okay, yeah. I'm used to using Jupyter ones, so I have to relook for the buttons. Okay, delete this. And I'll start with some text. So we can put some text in here, through HTML code or something else. I'll just throw some HTML to simplify it. What's first? Import modules. And I like to just throw these in as comments. And any type of notebook program that you're on, maybe not any type, because programmers often like to customize things. So I certainly haven't seen every single one that's out there, but definitely on the most popular ones you're most likely to hear about. If you push Control and Enter, it will run the current cell. And if you push Shift and Enter, it will run the current cell and then create another one below it. Otherwise, if you just run the current one, you have to hit the new cell button. So we have text cells and then Python cells. For this example, I'll need one library. I'll import the ABC library. And you do kind of have to watch for something. ABC should be in the default installation of Python. So it's not anything we have to bring in. It stands for Abstract Base Class. Yeah, I wrote the words on the board. Abstract Base Class. And we usually just write ABC. So we're going to use this abstract class for the base. So what I have in mind is some shapes. So I'll make another text cell. Whoops. Put this down. Oh, there we go. I'll make another text cell to mark this up. Some shape classes. All shapes will have an area method. So that's kind of the thought that leads into the need for abstract. So we have certain things that we know every shape's going to have. I'm going to keep it very, very simple and just do the abstract class. But one of those things, so we know that any geometric shape we have is going to have an area method. If we're making this class that's sort of the parent of all of our other geometric shapes, is every shape's also going to have a name, right? Let's make a class called shape. And I'll just kind of start putting some things in here. We need our initializer. And like we saw the other day, it needs a reference to itself. Every shape is going to have some stuff, a side method, names, all sorts of things we might need. I'm just going to strip this example down though. For here, I'm not going to do anything in the initializer yet. I might not do anything at all. But one thing that we do know every shape's going to have will be an area. But then we kind of hit a problem, right? Define a method called area or get area would probably be a better name for it. Because for our parent object, there's going to be other methods in this. Like, gotta think for a second. I'll come back to this. I'll just pass on that right now. But eventually we need something like the equals method, right? We want to know how this shape is going to be equal to another shape. The cell and the other. And the area kind of seems like the most sensible way to say two shapes are equal, right? There's lots of different things. On squares, we have the side length. Triangles would also have the sides. But a triangle with side length of 1 is going to look very different than a square or side length 1. One of those is going to be considerably smaller than the other. A circle doesn't even have a side length. The side length of a circle is technically infinite. Has a radius, but a circle of radius 1 is very different than a square of side length 1. So we need something in common, but all shapes have an area if we're talking about 2D shapes. So that's a nice thing to check to define our equality on, right? So if self.get area, oops, I just realized I forgot the word self up here. If self.get area is equal to other.get area, then we'll say these are true. These are the same shape or equal shapes. Otherwise, we'll return false to say they're not equal. Then another base one, whenever we define what it means for our shape to be a string. Because we might need to say print at some point. Create a string, self, return. It's a good way to describe every shape in general. Stuff that we know. You're gonna have a name and an area. I left name out earlier. That's just filling space unnecessarily. Not anything we'll necessarily need at this point. But we could return a string like this shape. Zoom buttons are in my way, sorry. Here. This shape has an area of self.get area. That's a good way to define every shape. It's something we can say in general about all of them. But we're hitting that problem. We're going to have lots of shapes that are child classes of this: squares, triangles, circles, hexagons. Yeah, the list goes on and on and on. But for the parent class, it's hard to say what the area is going to be. So that's where abstract classes come in. We know that we will have a get area when we're doing anything with geometry. Everything we do in geometry, there's going to be an area for it. So it'd be nice to just go ahead and define that here so we can start using it with polymorphism. Sort of like what we're going to see when we get back to our primary example here in a little while. And to do that, we can extend the abstract base class. Again, there's a parent-child relationship, but we do have to do it in a special way. We want to say meta class equals abc dot abc meta. Maybe a little later in the semester we'll see different ways we can do inheritance. This might be the only one we'll see, but we can do more than just put the class name in there. Even shoving Python into 16 weeks is kind of difficult to fit everything. So there are more refined ways we can pass things in. And in this case, we kind of have to. So in this ABC module, we can set a particular, instead of just a class, set some metadata about this class, about what the parent class is. And that's what this module holds. Thanks for that. And then whenever we have an abstract method, these ones that we don't know what that's going to be like, we can throw an annotation in there. So at abc.abstract method. Yeah. You notice there's abstract class method, abstract property. So there's other parts of abstract too. We're just quickly introducing the idea of it here, so you're not confused when you see it in another class. So now this is abstract. We know we're going to have an area method. We have no idea how to define it. We need to know what shape we're working at. So there'll be one by runtime, but we can't do it at this point. But we need that method already in order to put together what would probably make the most sense for checking equality between two shapes. When two shapes have the same area. At least that was my thought. Hopefully that idea makes sense. We need this method before we can say anything about it. And in our print description of it. Obviously, this example was explicitly put together for that purpose, but it is something that regularly shows up. And that's the idea of an interface, which you will see on day one of your 264 class. It's just a bunch of abstract methods that we know we're going to have, or in the term of rules, the methods that we will require an object to have in order to work with our software. Like, okay, it has to have these certain methods, otherwise we're not going to let it work here. Then we can create some child classes of that. I'm just going to do them in their own cell. Notice things are sort of independently located there, so that class gets its own cell, but it's not. It's all going to be still just one file, kind of. It's not like a bunch of separate files where we have to import them. That all happens in the background. That does happen, but it's all automated in the background, so we don't have to worry about that. And we can just think of it as like organization working notebooks. Okay, so some point later, that's why I wanted to use a notebook for this. At some point later, we'll be doing something else. In this case, just in a different cell of the notebook. But maybe doing something else in a different situation. We can use that abstract class to be the parent of a couple objects related to geometry. So like a square object. Those have it inherit from shape, and that way we don't have to redefine what equal is or what we want when we say print this shape. So it's going to inherit all that stuff, including that abstract method. So we do want to go ahead and override that. Here, there will be a definite initializer because a square we know a lot more about than just a generic shape. We know everything in a square is going to be based off the side length of it. Oops. One of those was supposed to say self. And now we know enough to go ahead and implement that method. We weren't sure what to type in earlier. So create that get area method. And that's just going to return the side square. Oops. Oh, I don't know why that didn't work. And it's self.side. Self.side. Anything else in there? Oh. And then we'll have another class called rectangle just to show the difference. That doesn't inherit from that. Like this is the idea I mentioned earlier. We make a module and somebody else goes to use it. They might think a little bit different than us and come up with things that don't quite work. So I'll set up their constructor or initializer with a length and a width for a rectangle. Set up all the variables as normal for Python, or all the data fields. I've already noticed a couple typos here. Talking and typing, that happens. If y'all ever notice typos, go ahead and feel free to say something. I'm talking the whole time I'm typing. I was talking to one of the English professors the other day, and she made the comment that there is no such thing as an interruption in Zoom. That whole thing that's always probed and drilled in your head since you were a little kid, or like raise your hand, wait politely. That doesn't work on a Zoom call. If you have a question, interrupt me. Just yell it out. That's kind of the only thing that seems to work on Zoom calls. And I really liked her comment the other day of there's no such thing as an interruption on Zoom call. Where was that? Oh, yes. So maybe somebody else is making this code, and they think a little bit different. So instead of saying, thinking about area, they're thinking about the meaning behind area. And they're going to give their stuff maybe not so clean of names. So instead of a get area, a nice term like that, they're going to create something called coverage. What does this rectangle cover? That's the meaning of area. So it's the same thing. Again, we would use the formula for the area of a rectangle. But there is kind of a problem here, right? And that their shape does not work with what we set up for shapes to be, right? It's not going to work with what we said it means for two shapes to be equal. So even if we said our square, create one of our squares with side length of 1, and one of the rectangles with a side length of 1 times 1, we can't check equality in a conditional statement because they didn't follow this rule that we set up for what it means for shapes to be equal. And that's where interfaces and abstract classes come in. It's like setting up rules that things have to follow so that we know the stuff will work together ahead of time. Then we get problems like this. And it doesn't necessarily have to be an outside programmer. If you come back to the program that you're working on 9 months earlier, there's a pretty good chance you're going to change up how you were naming things. We are very different people 9 months in the future than we were in the past, right? There's a constant flow of life experiences that alter us. So little names might change. So it's not just outsiders. Our future selves might be the outsider. And then we can check this by checking if it's a version of that. We can check when we use abstract base class, we can check the class directly. I almost never do that because I create instances first. I don't know, just some names. Cube base is a square. I'll give it some sort of area. And long thing is a rectangle. I'll give it a length and a width. It's all working up to this point, but we need to confirm that our rules were followed before we do things that depend on those rules we set up. Hopefully the idea of that kind of making sense. And we can check that with the built-in method. There's is subclass that we can use if we use the ABC method, but I never do that correctly. Because in order to do that, we have to actually call the class name. I guess it would go up here. And just the way my mind works, I always create the object first and then check it. There's this other method, is instance. And this needs the parent object and the child object. So first off is the child. We want to know if that cube face object is an instance of the shape class. And just do a quick little check like that to make sure the rules are followed before we do something that might cause the program to crash. Like in this case, check if a rectangle is equal to a square. This is coming out about the amount of time I want to spend on this. Do this thing, kind of do this quickly. Couple little, kind of finish it out quickly. I'll just print it out. Print. I know the area of this. And then I'll print whatever the area is. Square dot get area. Otherwise, I don't know, print. I have no idea what this is. We already talked about the main aspects of it. I'll just do the same thing for the other one. So we can see it, though false somewhere. See if long thing is an instance of those shape rules that we laid forward. So that's what it's abstract. We can't actually create an object from that class. It can only ever be a class. But we can compare our objects to that class to make sure they're related. I guess this one doesn't really matter. I'll print the same thing, but this line should never actually print. There we go. I fix the typo. Then I'll copy this. Else print. I have no idea what this is. And then once again, shift enter to run that. And it just gives us that little protection. A set of rules that things have to follow, and then we can check those rules to make sure everything's going to work. So as you set up packages, libraries, or modules, or multiple terms for it, like so many things, there's multiple terms, but they all kind of mean the same thing. Whichever way you want to call it, you set up those packages is the official Python one. You should use that word. You set up packages. You want to make sure when people use your package to create their own object, it's still going to work with the rest of the methods in your package. And that's kind of how we do it. Use abstract class and then use either is subclass or is instance to make sure it's one of our things. Or in the C family, when you go to the class that I want to make sure I talked about this before, you'll just use normal casting. So you'll take the cube face object and actually turn it into a shape object before calling any of the methods in. Y'all have seen casting in Python. That's like we have to do in strings. I guess like here we print a number, so we just do str to turn that number into a string. I don't think the word casting has shown up this semester, so I wanted to mention that explicitly. We would just do that with our other parent shape. But that's something that you might find you will encounter before long in your next classes. It's you'll definitely see it in the SDEV class. You might see it in other places. So just remember the set of rules. You can find a bunch of rules so you can make sure when other people use your software to create their own software, they follow all your rules so that the rest of your stuff will work with it. It's a basic idea. And then here in the notebook, yeah, I'm going to download this, and we can also download from a notebook to a Python file. Let's keep that. Then I'll throw them in today's class examples. That way they're back on GitHub instead of on Drive somewhere. Mostly I just wanted to show that if you download it as a regular Python file, if it's going to open, there it goes. You see all those cells just get turned into a single file. Notebooks have some nice advantages. A lot of people like them. Things are separate. You can go back to previous pieces or to later pieces. There's really nice organization. And I always like to throw in HTML because notebooks always run in browsers. So that means HTML code will work. And instead of comments, we can start putting together some nice documentation in those text-based cells. It's one of the advantages of those. How would this sort of thing apply to our example we were looking at the other day? Let me go open that stuff up we were looking at the other day. Oh, another thing in Python is that's not very strictly enforced. So you can very easily work in some wiggle room in Python, whereas in some of our other programming languages, most of our other programming languages, that is something that is very heavily enforced. Let's see, let's open all these at once. Yep. So back to the example we were looking at the other day. Okay. Zoom keeps making beeping noises at me, and I'm not sure why. Everything still seems to be running. Can you all hear me? Okay.
Yeah, I can hear you.
Okay. Yeah, I don't know why Zoom keeps making beeping noises at me. But let's take that concept and where does that apply in general? Because the other day when we put this together, we were able to find our methods. We didn't have any abstract stuff. We didn't have any blank spots to work with. So maybe that's what was going on. Somebody who's had a bad connection, I'll wait till this audio goes there. Okay, yeah, so the other day we didn't have any abstract stuff. We knew exactly what to put everywhere. So to make it abstract would be like to intentionally leave off things that we would know what it would be, right? Like everything had a rate, so we could call that abstract and leave it off. We put on later, but that's kind of unnecessary, right? That seems redundant because the reason we want to put it in the parent class is so that all the children have it, right? It's like a pyramid, it spreads outward. So if we don't put it in the parent class, we have to write it a bunch of times. So we know that stuff, and that's where polymorphism really comes in. So we use polymorphism to set up our methods when we go to use this stuff. So those classes we put together the other day, which y'all probably noticed got faster and faster and faster as the night went on. I did that. That was because it's so repetitive. That was by design. I think I mentioned it explicitly when I double checked the videos. Noticed that I didn't explicitly state that. That was by design to highlight the repetitiveness of it, the tedious repetitiveness of it. That is the same thing over and over and over again. Which is something that's going to happen one more time this semester, around week 9, I think, where there's just a whole bunch of tedious repetitive typing. of the same concept over and over and over again. So we'll see that again. So when we get there, it'll be another one of those examples. So it'll just get faster as the night progresses. But we have all this stuff set up. We're in our methods. Those were set up from before. We still don't have anything we need to tell pip or anaconda about. So requirements.txt is still blank. There's nothing we're omitting. There's also a blank file called init with 2 underscores, just like our initialize method. There's a file that's part of the manifest that has that same name. __init __.py that is usually blank. We just use it to rule out things from our manifest. For example, this is here, so it's something to point at. If for some reason we built a big package and we didn't want to use the gross pay method, we didn't want somebody to be able to import that and use it elsewhere, but they could have everything else in their module. We'd use that init.py file in the manifest to not allow that to be imported. I have an example of that in mind when we get to recursion. We'll see that soon. But for the most part, that's another file that is usually just a blank file, but our installers like pip and anaconda will crash if it's not there. So we just have to put a blank file with that name there. Makes it really, really easy. It's not much, doesn't get much easier than creating a blank file. So we have these methods, but they're kind of set up odd when we create them. There's a lot of repetitiveness over here, right? We created those employees, and the very next thing on our list of stuff to look at is list. So that's going to be even more organized soon. But then we'd have either a dictionary or a list or a tuple, something with indexing, right? We'd have just one name, it's square brackets. Everybody's seen that before, so I don't really mind talking about it, even though I'm not going to use it until after we formally talk about it in the lecture, right after this stuff, very next lecture. But we'd have just one name and then those square brackets with either a numerical index or a usually a string-based index on a dictionary. We can put other indices in there. Very few of them other than numerical indexing would make sense. And at that point, why even use a dictionary? We're going to use numerical indexes. We just use the list and cut out a whole lot of the typing. But when we have to call this stuff every single time, the thing is, and the reason we would use abstract classes and stuff has to do with polymorphism. Which computer has the? So remember that third key concept of joiner programming is polymorphism. Great big word for a really simple concept. Our objects have the ability to behave as other objects. In particular, a child object can always behave as a parent object. So even though we can't make this abstract, or we could, but in this case, our example is better not to make it abstract because we know what goes in all these methods. So if we make it abstract, we just have to type it a bunch. It applies to polymorphism. If we set up our methods to use the parent class, then we don't have to worry about whether or not it's going to work with the child class. It's not as strict as setting up a bunch of rules in an abstract class or interface in other languages, but that's where that polymorphism thing comes in. Whoops. So like this gross pay method, instead of setting up 2 parameters to pass in, what if we just passed in that employee data? That's the whole point of an object, is we have a specific type of data we need. And this is office management clerical type software. So we have some very particular needs for the data that's going to be used here. So we create an object that fills those very particular needs. And now that we have that data, we want to use that. That way our methods are set up to work with the thing specifically designed for what we need. So instead of passing in a couple fields, I'm just going to pass in one of those objects. And then down here, I will use that same check we did to make sure something was a child of the abstract class before we tried to do something like equality between a square and rectangle in the last example. The is subclass we kind of need to, that's restricted for the abstract base class stuff, but that is instance, that works with any Python object. So before we do this, we can check if is instance. So if this thing we passed in is an instance of employee, can I import that? Oh yeah. Make sure you import it if it's not, if it's in another file. Started to do this the other day and then decided I wanted to talk about abstract classes first. Because it's easier in Python. We usually do this and don't worry about abstract classes. So I wanted to talk about them first. It's not necessarily that it was needed for this. But then before doing any of this calculation, we can check and make sure that we have the right type of object. And then we can just work with that. So like if employee.getName is, we've already done our check. We know we have the type of data we need. So by the time this line runs, no matter which subclass of employee, where we had several layers on that picture drawn on the board, be 3 or 4 layers deep, or maybe just custom layers deeper. We know that it's going to have that get name method because it's a child of the employee class or a child of something that is a child of the employee class. So that's the polymorphism. We know we can be certain that it's always going to be there because it's inherited. Same thing with our rate. We have that custom type of data. So we want to use that custom data as much as possible. Else, turn none. I'm just going to put pass. I'm not even going to return the null. I'm just, just don't do anything if it's the wrong type of data. Not a warning message or not anything. That's a lot of times warning messages show up in like tutorials and textbooks and early steps, but you never want to show your end user a warning message, right? Even if it's a warning, not an error, that's going to make people very, very nervous very, very quickly. So you passed the classes that have the word introduction in the name of them now. So you should probably start working on trying to stop showing warning messages. Minimize the messages to the user. And messages to the user need to be things like a prompt or really labels on a GUI. We'll get the GUIs next Tuesday, maybe some on Thursday. But you never want to show your end user a warning message because they're going to panic. They're not going to know what that warning message means, right? So I usually just don't do anything if it doesn't fit those criteria. But does that make sense? So now, no matter whether we have where's the example? Whether we have a laborer or clerical or an upper management, which I need to fix this error we saw at the end of the night the other night, was coming on close. $43.21, terrible salary. Let's turn this into a nicer salary so we don't get weird numbers. It doesn't matter whether we have a laborer or a clerical or a manager. We can call that same method without having to worry about any of these other details by just passing that data type in. This is the use level. All of that other stuff would be set up already. The classes, the payroll, and this is probably the level you're looking for. You're used to working with, right? You import a module and then start using it immediately. So all that stuff is already set up somewhere else. It just so happens that right now it's open in the same IDE, but essentially it's already set up. So now that we're using it, we don't want to think about those fine details about what's the name of the method to access the rate of pay. We just want to, it's like, okay, we have our data. Let's pass that data all in as the single item to the method that accepts that single item. Hopefully that analogy made sense. Let's see, what is it? It's spring of 2022. I've been teaching here since fall of 2018. And I still feel like that analogy is inadequate compared to what I see in my head after decades of doing this, of programming, knowing about computers. I'm trying to get the words right for it, but hopefully what I just said makes sense. At least point you in the right direction. Experience, some of it is really hard to put into words, right? It's things that machines do. Machines do not process the way humans think, so our language falls short. That's part of the reason that, like, when you go look for a job, they want a certain level of experience. There's that things where the language falls short because you can't read it in a book. You can't hear it from a lecture. You just develop an intuition for it because it's how a machine works, how a machine processes, not necessarily how a human thinks, and it doesn't go into language very well. So sometimes I'm often looking for better words. Hopefully that makes sense. We have our data type specific to our program. So now that we're at the use level, we don't want to think about the details after we load everything into our type of data. Like after all this stuff gets loaded into labor, we never want to think about those details again. We have that whole object and the details are just enclosed in it, and then we can pass that object around. Is what's going on here. And the abstract classes and interfaces follow suit with that. And now this one should be okay. Because that same thought, it's enclosed. Oh, whoops. That's what's supposed to go here, right? Employee 1. And 2. And 3. And then down here where we go to print it, what it means when we say print this object, that enclosure of data, all is one big assorted collection. So we don't have to think about the details for. We've already defined what it means to print that out, which is something we've seen in other items in Python. Just explicitly stating it for our items here. Did I get all the changes I needed? I don't think this one was finished, I think. So now we'll just pass in that whole object. Yeah, this isn't going to crash. We would need one more check. I don't think it's going to crash in this case, but if somebody was to use this method and try to pass in something that wasn't that data, it's going to return it. It's not returning anything, right? But the very next line tries to return stuff. So we would need another check or maybe return something. Yeah, let me close this. And yeah, that right there is, well, I like to run things in independent tabs. So we don't have to close the ID program. I'll just return the default value. And in this case, I'm going to return a terrible default value. 0 is the worst thing to see on a paycheck, right? That means as soon as a human looks at it, as soon as a human sees that number, they're going to know something's wrong. So in this case, I think a terrible default value would be the way to go. Instead of an error message, the human will figure out that something went wrong. Instead of the computer telling them something went wrong, because that's going to make people panic if they're not, say, computer experts. That way we don't actually need a second check there. We'll have a number, just sometimes that number's not a very good one. But it looks like this still kind of works the same. It's asking for Bob's name, that's our employee's name. How many hours did he work? Maybe he worked 32 hours. Oh, I missed it somewhere. Payroll drivers. Oh, the line numbers underneath there. Oh, there it is. Instead of just passing in the number, which works with any software, we want to work with our own data type. So employee.get rate. I believe I changed it somewhere else. Try that again. Let's say Bob worked 32 hours. We got that, how much he made. Then the next employee, maybe she worked a little bit of overtime. That came in. Oh, Becky's on a salary, so we can say she worked 2 hours. Still got quite a bit. So might need to adjust that, right? So is that extra level in there? I'm gonna come back over here, and that'll be the last thing to do on this example for now. And do the same check on a lower level. They're not abstract, but we always have this is instance. We can, it'll return true or false, and we can check what type of data we have. So before we do the rate, let's say, what's a good way to do this? It was something on this computer. I have an example of this. I don't think I did. Well, I know I want to check if something is an instance of the manager object. If the employee happens to be a manager, then we need to do the salary stuff. Otherwise, we'll do all this stuff. I think that'll be enough. Any thoughts? I think just saying 40 hours will be good. Oh, then we wouldn't even need an else, would we? Oh, yeah. Yeah, we would. And then this stuff doesn't need to be in the else. So if they're a manager, we just automatically say they got 40 hours. And then it applies to the salary because we already calculated that. As a reminder, that was over here as part of the class. Managers get a salary. So
is there a reason you're writing out 40 instead of using regular time like you did with the other stuff?
I forgot about that. Thank you.
No problem.
Yes,
I wasn't
the reason-
sure.
Yeah, the reason is, from 5 days ago, I forgot that was there. Good catch. Please point things like that out, because that is a much better time, because we're good switch to a company where 35 hours counts as full time. Or somebody that wanted more work put in. I completely forgot that was there. But that gives us a way that to distinguish between the managers or the regular employees. And we only have one type of data to work with. So once we create our data, we never have to worry about the details inside. That's another thing about encapsulation. It's all described as hidden. The details are hidden. So one instructor I had over at IUS used to always like ask the question when we're talking about optics. We ask, so how is it implemented? And the correct answer is we don't care. It's already been implemented. It works. We don't care how it works. We just know that it works. And that's part that goes along with encapsulation. It's only the person who creates this object or creates this class needs to worry about those inner workings. Right? How many times have you gone through those Python, the Python language, all those scripts that were installed that give us things to use, those pre-built things? How many times have you gone through it? They're encapsulated. We don't really care how we don't care how the inner workings go. We know that they work and that we can use them. So one more thing that you will often hear referred to with encapsulation, of just the not caring part. Let's see, so maybe Bob worked 45 hours. I guess that's about right. Could check it with a calculator, but we did that the other day, so I assume that's the right number. If I could relate that to other jobs, $17, work some overtime, give out. Yeah, that seems reasonable to paychecks I've had in the past for jobs that paid about that much. See, maybe this week Sally worked 23 hours. Oh, it didn't even ask us about the manager. That seems about right. She doesn't get a salary, or it doesn't matter how many hours she works. We don't need to ask that. She just gets the same amount no matter what. So if we're running it again, maybe the following week, Bob works 23 hours and Sally worked 48 hours. And once again, it doesn't ask you about the last one. And then once our data is all enclosed in that, we don't really have to think about it again. Just the initial creation, the organization of it, and how it's implemented. We don't have to worry or even care about that part. Well, we did because we designed that. And that was a past example, so we need to keep those concepts in mind as you move forward. But that's the general idea of it in encapsulation. It's all enclosed. The capsule's sealed up. We don't need to look inside it. We know it's going to work. Like a computer itself, right? There's a lot of pieces in here. Most people have no idea how they work. Right? If they take out all the screws and look inside the laptop, they would be quite confused. But a good number of those people that have no idea how this stuff works know exactly what to push on the keyboard or the mouse or a touch screen if that's relevant. They know exactly which buttons to push to get whatever they want to happen. So they don't have to worry about what is encapsulated inside of the machine. The machine works like it's supposed to. So you want your objects to follow that trick. Just like somebody that might not be a hardware expert on a computer can use a keyboard to input some stuff. Once the object's created, you just want to input some data to initialize it and then never really worry about it again. So we can use, and that's where we start to use polymorphism. We want to set up our methods to be polymorphic to any type, any of our data types. So sort of the parent class for the highest level of parent we can get in our package. So that it's going to work with everything else or as much as possible afterwards. And then all of that stuff is enclosed and we don't have to think about it. So it doesn't matter which one of these we use. We use a regular employee one, a laborer, the clerical object, the regular manager, middle management, upper management. Every single one of them will work with this because it's a child of employee. So that's how polymorphism gets implemented. In some cases, we might not know the finer details at that higher level, but we know something will be there for it. Like that shape example. At the very top level, the most generalized generic version, we have no idea how to calculate area because that is very explicit for different shapes. But we do know there will be an area calculation for every shape we want to work with. So we can include that at the top level as an abstract method, which then causes that to become an abstract class because we can't actually implement it if that method's never actually, if that method is still kind of just blank. And then we can take that further and set that up like a set of rules that we followed to work with our software. Those are concepts you will see over and over again. They're usually introduced at the 200 level. But in the Python course, in the Python programming language, we don't really have abstract classes and interfaces. We kind of have abstract classes with this ABC thing, but it is a little different than what every other programming has. So I wanted to talk about those concepts so you're not taken by surprise with it in future classes. You kind of have an idea of what's going on. In Python, we can do the easier thing of just using general polymorphism to set up some sort of rule things with just this simple condition right here. If something is an instance, then we'll work with it and some sort of fallback. And now that you're past any classes that have the word introduction in the name, try to stop spitting out error messages. Because error messages will make your users panic. And sometimes it takes some, we have to think rather intently on how to resolve something without just spitting out an error message. The goal is to always keep the program running. And spitting out an error message is a sudden end to the program. So that's the thing we never want to have. So it takes some practice. You might have to start practicing with it now. It's not going to affect your grade in this class. You can't see a way around it. Just spit out an error message because we're still learning this stuff, right? But please keep that in the back of your mind. That you want to start working towards that goal of never spitting out an error message for the user to see. Never let the user know there's a bug in the program, right? Let them think it works perfect. Hide the error messages, and that's the idea of exception handling we will see soon. Thursday, we can get into list and then GUIs. I think we probably will go with the TK interface package. That's a classic. It was written in a language called TCL, but pretty much every modern programming language TCL was used in the development of just about every modern programming language. Sometimes it's not fully integrated like as in Python, but we almost always have the TK interface package. And it's a classic. It's the one all our other ones are based off of, so probably we'll look at that. I'll point you towards some other ones. WX Python's not favorite. We'll get to that in a couple days. So first off, talk about lists and dictionaries and tuples and sets and collections, which you probably already know. Everybody here probably already knows exactly how how collections are going to fit into this general class example we're building here. We can already see that this would be going better with the collection than separate variables, but that is coming up on Thursday. It's an active subject we learn by doing. Give this abstract class thing the ADC module. It's in every installation of Python, so it will, you don't have to do anything special to get it in there. Give that a try. Might have to mess around with stuff, and you might have to look for examples where you would use that. So you might want to Google tutorials and look for that, or actually tutorials are probably going to be very, very stripped down, so we wouldn't even use it much. Trying to come up with examples where when you make the parent a parent, it's going to have lots of objects that we wouldn't know how to define the method for. So you might have to think kind of hard to come up with examples for that. Or, yeah, there's homework due on Thursday. We got 30 minutes left in our class time. As always, please use this lab time productively. Text messages and Ivy Learn messages make noise on my phone. Those are two things that I will hear and can jump back in the Zoom call immediately. Otherwise, I will see you all on Thursday. Does anybody have any questions for stop the recording? Okay, I assume the silence means no questions, so I will see you all on Thursday. Y'all have a great night.